A little about myself. I'm Sam Henricks. Thanks for the introduction, Natalie. I work for Sapere Consulting. This is a project I'd like to talk about that we worked on with Chelan County PUD. So a little bit of background, help understand the project a bit better. Chelan County PUD is a public utility in the state of Washington, um, and they provide power to their customers through hydropower exclusively. Because they're in Washington, um, they have a lot of weather, and it's a bit more rural. They have a lot of vegetation, and so that makes power outages very frequent. Windstorms, ice storms, anything like that can take their transmission infrastructure down. And because of that, they're moving to underground cables. So instead of having transmission above ground, when you're driving past and you see them, they're switching to underground cables. And that was sort of the advent of this model and this project. So going over the background, they're spending this money on their infrastructure, primarily their cables. And the PUD wanted to know, if we spend, X amount of money, how's our reliability going to improve? So the key metric there is SAIDI, just on average, how many outage minutes are you experiencing per customer per year on average? Um, and so they had these estimates, and they had these goals, but they really wanted to have some data-driven support for it. So, I mean, if you're investing millions of dollars, you want to have a reliable estimate of what the outcome is going to be. And there's a lot of inputs to keep track of sort of on your own. If if we change this budget, this number has to go down. What's the effect? How much labor do we need to actually implement it? And the fourth primary drive here was a worry about their cable assets as a whole. So what they referred to it was cablemageddon, which was this fear that one year the underground cables would fail sort of all at once, and they would have this worst case scenario where they weren't able to keep up with the outages. So look at some of the data and some of the relationships that's included in this model. There's a lot of historical analysis on outages. So how often do we see things like snowstorms producing a widespread outage? Um, Another very common cause is squirrels and rats. So we actually have some data on animal populations in the state of Washington, as well as installation on animal guards to protect against those. The best part about this model is the asset registry for transmission equipment. So the PUD does a great job of keeping track of all of their assets. So that could be a transformer, that could be an underground cable. They're actually in the process of creating a registry for all of the vegetation in the county. So actually going out and finding and keep track of trees, bushes, things like that. Which I'm excited to dive into eventually. Um, and also there's some Weibull curves for their assets. So, if a cable is 25 years old, then what's the likelihood of it failing in any year? Going into the architecture, of course, simulations are primarily done in AnyLogic. So the backbone of this model and this tool is the single simulation in AnyLogic. So you provide a set of inputs. In this case, it's primarily resource allocation. How many employees do we have? How many hours do we have to spend on proactive cable maintenance, things like that. There's also some exogenous variables, looking at what the population change is going to be like in the county, looking at what might happen with animal populations, costs, things like that. Um, so that's the single simulation, and you get your outputs. Obviously, we can use that in a Monte Carlo setting, running that hopefully hundreds of times. The user is patient enough and getting a possible range of outcomes, getting those confidence intervals. And finally, one thing we've been experimenting with is the optimization. And we have two pieces there. The first would be given a set of total budget or total resources, place the money, place the labor in the right spot to see the best improvements to reliability. So if we have $10 million overall, how can we split that into the different maintenance types and the proactive infrastructure improvements to see the best reliability? The other optimization would be we want to see this reliability number. What kind of money, what kind of resources do we need to spend to get there? And so those two things have been really powerful and have been the most interesting result, really. So this is a big piece of the architecture is the cloud API. Like I was saying, we have that sort of backbone in AnyLogic. We have the simulations. So what actually happens is a user from the PUD goes onto a web app we made for them. They supply the inputs, and then we go and request the experiment from the AnyLogic API. This has been a really big change for us. Our firm has used AnyLogic in the past, and using the cloud APIs sort of unlocked a new way of delivering the products to customers, which has been really great. We have this custom backend that stores experiment results, which is really nice. And that also unlocks new things. We have control over the data. We can run regression. We can do our own visualizations, things like that. And on the front end is also important. I think as a developer, it's easy to just sort of make the model or the simulation and hand it off. I know this was definitely a learning experience for me. Creating a custom front end, creating something people want to use, and that's intuitive. And using the API was nice because we have a lot of control over the inputs. We can hide things from users easily. We can change names. We can also change which inputs people see based on who's logged in and things like that. And then we have the web application. Talking about this stack just a little bit. I know this isn't terribly interesting. We're using Python, Fast API, React, and Mongo. And then, like I was saying, this allows for very granular control. So I lost my train of thought. We can sort of customize what the inputs look like, and I keep speaking on this, but this has been really important for us. It's something that's been really nice. Just makes everything smooth, makes everything streamlined, and easy to use. Another thing is the unique outputs. I'll speak to this more in a little bit, but a lot of new stuff is possible. So part of this is using AnyLogic, but also using some custom Python. That's been a nice part about using the API is we have the sort of heavy lifting with the AnyLogic simulation, and we get the data, and then we can do nice things with it. And that's been really nice. Recently, we've been adding in some GIS. I have some screenshots of that. And the nice part about the GIS is GIS is really interesting. And it also shows how this product has been very flexible. So as they sort of get a handle on it and experiment with it, they say, oh, what if we could do this? What if we could look at the different areas geographically? Now we can add that very easily. And then also we have these new experiment types. I know I would like to experiment with machine learning with this application and try and do some more prediction using the simulated data, but we have not gotten to that yet, but it is certainly very possible. And then I just have a few screenshots here. Unfortunately, I wasn't able to share the live demo. Here's what we can see. This looks like this is obviously not the AnyLogic interface. We have these different experiment types set up for them, as well as one thing that we really like is being able to add in this this help functionality. So the users can just click the question mark. They're able to get, based on the page, what sort of information they're looking at, and just a little bit of help. This is the GIS that I was mentioning earlier. They are able to drill down into the different, they're called substations. That's the easiest way to delineate between the different parts of the county, and what the customers are. So they're able to click around and toggle between these and see different key indicators. So like SAIDI here, for example, is their primary reliability metric. They're also able to see number of failures, number of replacements, things like that. So finally, talking a bit about the results. One thing that was really interesting was there were some new strategies that were discovered during this process. So I mentioned at the start that the county was very concerned with what they called cablemageddon. And because of that, the primary focus was on underground cables. They really wanted to get that sort of drilled down. But during data discovery, during the process of building out this model, finding the mathematical relationships, as a third party, we were able to see, hey, I know we're worried about cables, but let's take a look at the animals for a little bit. And I think this is just a good showcase for why simulation modeling and is so powerful in system modeling, really. In the act of defining the system, you're really going to find out things that you didn't know at first. And so that was really cool for us. And once we were sort of aware of this, we were then able to test that out with the product, which was really cool, and have some new strategy. So eventually, the stakeholders for our project were able to use it to get their budget approved by the board. I wish I had a report on how accurate the model was, but we'll have to wait a couple of years for that, which is tricky, but I guess it's something to look forward to. But the key thing is that they're very confident. They have their budget, they know they have a plan. And really they can rest easy knowing that, if they keep doing this, the worst case scenario, the thing that really keeps them up at night is not going to happen. I think that was really neat for me as well to be able to provide that for them. And that's what I have for you all today. Move on to questions. Obviously my name's up there, Sam Hendricks. There's my email and my phone, as well as our company website if anyone would like to reach out.